Okay, so for those of you that are watching the video, we all have M&Ms, and they're chosen one, and they are sucking on it to see what happens to the outer candy shell. And guys, what is happening? It's dissolving. So as it dissolves, you can imagine yourself performing the derivative on the outermost function. And that gets you to the chocolate. What's happening to the chocolate?
Oh, there it is. It's dissolving.
It's dissolving, so you're performing the derivative on the inner function. Anybody through the chocolate yet?
Yeah.
And what did you find?
A
A pretzel. So you keep sucking on the pretzel and it dissolves away, and so now you're performing a derivative on the innermost function. So yesterday, Tristan, we did f of g of x and found the derivative. Today it's f of g of h of x. There's a function in a function in another function. So we're adding a function. A little bit. Probably not.
Uh-oh.
Are you serious? I figure if you have gluten-free, you know your issues, and you probably wouldn't have put one in your mouth. You guys are just about adults. All right, here we go.
She literally told you that. Seriously, the second word.
Thank you, Alex. You may eat the rest, and now we're going to go fill in our worksheet. Okay, so when we look at number 1, guys, for some of you, it's going to help to rewrite this so that it looks like an M&M. So we have sine of 3x, and the whole thing is being squared. That's what that little 2 in there means. The whole answer is being squared. So our outer candy shell, our outermost function, yesterday we used u's. You could put u squared, but we know really what it is that you are taking the sine of 3x and you are squaring it. So we need the derivative of that outermost function, that candy shell. Just 2u, or you could, up here, put the u in the front with sine of 3x, and if you wanted, you could put parentheses around it with a 1 there, right? Because that exponent has now been reduced to a 1. Now we're at the chocolate, we're at the middle function. After we take the derivative of this outermost function, what are we left with? Sine of 3x. So let's dissolve the chocolate. Let's find the derivative of sine, which is cosine. Leave the 3x alone for now. And now we've got another function, the pretzel, which is 3x. And the derivative of that is 3. So just like yesterday, we multiplied the derivative of f times the derivative of g of x, like the functions. We're going to multiply this time the derivative of the pretzel times the derivative of the chocolate times the derivative of the shell. So the 3 derivatives get multiplied together. Now, I'm kind of going to simplify as I go. I've got a 3 times a 2 here. So I'm going to put 6. And then all I have left is the sine and the cosine. So times sine of 3x times cosine of 3x. And that's your answer. Questions on the first row? You just multiply the derivatives all by each other. All right, number 2. For some of you, it may help you to write it out as tangent of 3x squared. The whole thing is being cubed. That's what that little 3 means. Let me zoom in so you can see that. The whole thing is being cubed. So our outer shell, if you prefer to use the u method, you could put u cubed. But some of you are going to be fine just saying tangent of 3x squared and the whole thing is being cubed. So now we find the derivative of the shell, and what do we get? Good, 3 squared. Or if you just want to write it up here, we've got 3 times the tangent of 3x squared, and that whole thing is being squared, right? You could put parentheses around it and square it, or you could put the little 2 right there, kind of like you're supposed to. It means the same thing. Okay, what's our middle function? The middle layer.
Tangent of 3x squared.
Very good. Tangent of 3x squared. And what's our derivative of tangent? She's correct. Secant squared of 3x squared. And what is our pretzel level function?
3x squared.
Our derivative, of course, is 6x. Same process. We take the derivative of the innermost function times the derivative of the middle layer function times the derivative of the outermost function. So we can kind of do some of this kind of as we go. I've got 6 times x over here times a 3, so that's like 18x. And then I've got tangent squared 3x squared, and I have secant squared 3x squared. My pen is too wide to kind of fit all that in, sorry. I'll zoom in. Any questions on the second row? Everybody okay? Okay, you try to move ahead and tune me out, but I'm going to keep talking on the third row in case y'all need it. So in the third row, I've got cosine of x squared, and the whole thing is being squared. So the derivative of that, I take the 2 and throw it to the front, so I have 2 cosine of x squared, and technically that whole thing is now to the first power. You just don't have to write it. So then my next layer, my next function, is on the inside, and it's cosine of x squared. The derivative of that would be negative sine of x squared. Then my innermost function is just the x squared, and the derivative of that is 2x. So I multiply 2x times negative sine x squared times 2 times cosine x squared. So if I want to kind of simplify as I go, I've got 2 times a negative, there's a 1 there, times 2. So I've got negative 4x times cosine x squared times sine x squared. Anybody get there before me? Good. Are there any questions on the third row? Okay. You guys are going to be able to do kind of the rest on your own, and you should be just fine. On 1 and 2, don't be confused because that's not a pretzel M&N. It's just a regular M&N like yesterday. It's the same process, it's just not on a table. Yes, ma'am?
Is the pretzel thing, is it gonna happen just with functions like?
Trig functions? No. It happens in other ways too. Yeah, and I'm glad you asked because we are going to do one real quickly. It can get quite complicated. On the back side of your paper, you see all that kind of empty white space? We're going to use it. There are problems in your assignment that could look something like this. We have square root of 2 plus the square root of 2 plus the square root of x. Yep.
Wait, we're gonna have to do something like this?
Yes. This is one of the odd problems from your assignment today. If that makes you feel any better, I hate it as much as you do. I'm not a fan, but I will do it. Okay, let's rewrite this thing because this could get super confusing. So we've got y equals our outermost kind of parentheses. We know that there's a square root here, so it's to the half, right? You guys see that? And on the inside, I've got 2 plus, and I've got another radical. So I've got another set of parentheses. Put that cup on the floor. to the half. And then I've got a 2 plus, and I have another set of parentheses around an x to the half like that. We've got 3 square roots, so I have 3 exponents that say to the half. Would you guys agree that those mean the same thing? Yes. Okay, so we have an outermost function. Here's the hard outer candy shell. And then we have sort of our next, wait, nope, this right here is our next function. And this right here is our last function. That's the outer function, sorry. So we have 3 functions there going on. So here we go, derivative. Outermost function comes first, because that's what dissolved away first, was the outer candy shell. 1/2, we throw it to the front. We have 1/2 times this whole inner piece of 2 plus, open parentheses, 2 plus x to the half, close those parentheses, and then that whole thing is to the half. Wait, I missed a half, didn't I? And that's a negative, sorry. Yikes, sorry about that. So this exponent up here, where's my little pen? Did I lose it? I think I did. There it is. So this half right here, we subtract 1, we get negative a half. Everybody else stays the same. Times, now we need to multiply by then the derivative of the next layer. So that's this little half right here. So we throw him to the front. Well, actually, okay, let me back up. If we're taking the derivative of the inside, you do need the derivative of 2, which is what? We need the derivative of this entire inside, guys, but the derivative of 2 is 0. So you don't need to put that down, because it's just 0 plus the rest of this guy here. So we have a half times this whole piece that's left here, 2 plus x to the half. And now it's not to the 1/2. 1/2 minus 1 is negative a half. So now we've changed this one right there. Last one, we're on the inside. Derivative of 2 is 0. Derivative of x to the 1/2. 1/2 x to the negative half. I heard it. So now we've taken care of that group. Complete our circles here. Here we go.
Well, we'll use the whole thing.
Say again?
We do like the full, because I only have the third step.
Now it's just a matter of simplifying it. This is the derivative. We just need to make it look a little prettier. Now, if you look kind of what's going on here, you've got 3 exponents that are negatives, which sends that whole thing where? To the bottom. I've got a 2 on the bottom, a 2 on the bottom, a 2 on the bottom. What's on the top? Okay. If I have a 2, a 2, and a 2 on the bottom, what's 2 times 2 times 2? 8. And then I've got this whole piece is to the negative 1/2. So can't I shove all of that in a radical? So I have 2 plus, there's another radical, 2 plus, another radical x. That was our original. And now this guy right here is also to the 1/2, so times radical 2 plus radical x times the last one, which is just radical x. And you can just leave it like that. Yeah. So that one didn't require a lot of work, like a lot of writing. It just required a lot of thought. All right, so your assignment is to finish this worksheet. And page 137, 22 to 56 even. Nope, Just kidding, I'm nicer than that. How about 22 to 36 even? And, what did I say over here? 44 to 50 even. There you go. So here, stop on this because it's still recording.